Hello, ladies and gentlemen. Welcome back. This is Matthew Farrow speaking again, and we'll continue with our exploration of the virtual assessment problems. Here in this video, we'll be looking at the question 3b that talks about differential of an inverse trig function. And in this particular video, for this particular question, I am going to break it down into segments. So, because here we can look at what is happening with the inverse sine of x, and we also need to know what is happening with y equals to 2 to the power of x squared. So we're going to look at these two things first before coming back to the main guy. So we will start with which one should we start with? Let's start with the inverse trig function. So when we have y equals to the sine inverse of x, how do we take the derivative of this? Very simple. I could actually just tell you what the answer is. I know that y prime is equal to 1 over square root of 1 minus x squared. But how do we get there? So it's a nice activity to actually see how this is derived. So what do we do? First and foremost, we know that when y is equal to sine inverse of x, that is the same thing as saying that sine y is equal to x. Okay, so if it's like saying y equals to f inverse of x, then that means f of y is equal to x. That's just what it means with inverses. So since we want to get the y dx, I can take the derivative of both left hand side and the right hand side with respect to x. So that is, I want to do d dx. So d dx of sine y and d dx of x. So on the right hand side, that is just simple. Dx over dx is 1. The derivative of x with respect to x is 1. But on the left hand side, it's a little bit tricky. So the derivative of sine y with respect to x is cos y times the y dx. Why is that so? We have simply applied the chain rule. So it is generally when y equals to sine f of x. So if it is just y equals to sine x, then y prime will be equals to cos x. It's as simple as that. But if it is, if we have a function embedded inside the sine function, that's a composition of two functions. If sine is composed with f of x, then the derivative, the y dx, is equal to not just cos f of x, we multiply that by the derivative of f of x. And if we look at this one, the inner function here is y. So if we take the derivative, that will give us cos y times, so the f prime of x here is the y dx. So that tells us that we just need to divide by cosine of y to get the y dx. So this is the y dx is equal to 1 over cosine of y. Okay, but this, we cannot stop here because we want to have our function, our derivative function in terms of x. So what can we do? We know that sine y is x, but here is cos y. Is there any relationship between sine y and cos y? Absolutely yes. So we know the Pythagorean identity, sine squared y plus cos squared y is equal to 1. So if this is true, then it means that first and foremost, cos squared y is equal to 1 minus sine squared y, and then cos y is equal to square root of 1 minus sine squared y. Beautiful. So it means the y dx here is 1 over square root of 1 minus. Why have we gone through that stress? We want to be able to use this information that we have. So we don't have the direct relationship between cos y and x, but we have a relationship between sine y and x. Sine y is just equal to x. So we are leveraging the relationship between sine and cos via the Pythagorean identity. Okay, so now that we have this is equal to 1 over square root of 1 minus sine y is x, so sine squared y will be x squared. So in a nutshell, we have that the derivative of sine inverse of x is 1 over square root of 1 minus x squared. That's the first part. The second part is for us to take the derivative of 2 to the power of x squared. So we are going to use chain rule here, knowing that the derivative of 2, or generally a to the power of x, is a to the power of x times natural log of a. So if we know that, we can use the chain rule here. So first and foremost, let u be equal to x squared. So if u equals to x squared, then it means y is equal to 2 to the power of u, because we have represented this with u. Then the u dx, that is derivative of u, is 2x, while the y du, the derivative of y, according to what we have written here, is 2 to the power of u times the natural log of 2. So what does the chain rule say? The chain rule says that the y dx is equals to the y du times the u dx. And in this case, that will be equal to 2 to the power of u times natural log of 2 times 2x. But what is u? We remember that u is equal to x squared. So this is equal to 2 to the power of x squared times 2 natural log of 2 times 2x. That is the derivative of 2 raised to power x squared. So having gone through all of that, we can now come back to the original question. So we want to take the derivative of sine inverse of, sine inverse of 2 to the power of x squared over x squared. Beautiful. So how do we go about this? So this we have seen that this is a composition of functions. We have embedded this quotient inside this inverse trig function. So we are going to use a lot of machinery here. The first one is the chain rule. So let u be equal to what is inside the parenthesis, 2 to the power of x squared over x squared. So it means that y will be equal to sine inverse of u. Beautiful. Then for us to be able to use the chain rule, we need the u dx and we need the y du. The y du, using the result that we got here, the y du will be equal to 1 over square root of 1 minus u squared. But to find the u dx, that will take some side attraction again. So let's see. Let's come over here and let's do this quotient. 2 to the power of x squared over x squared. This is our u, and this is our v. So for us, this is a quotient. So u is equal to 2 to the power of x squared. V is equal to x squared. The u dx, according to what we got up here, is 2 to the power of x squared ln 2 times 2x. Then the v dx is equal to 2x. So what is the y dx? Again, you remember that quotient rule says the y dx is v du dx minus u dv dx all over v squared. So in this case, that will be our v is x squared times du dx, the whole of this ugly looking stuff, 2 to the power of x squared ln 2 times 2x minus u dv dx, so this and this, which is 2x times 2 to the power of x squared, everything over v squared. That will be x to the power of 4. And good. So this is our the u dx, because our u, this is actually our u. So we are going to copy that here. So copy, paste. So this is my du dx. So using the chain rule now, we are using the chain rule because this function u is embedded inside the bigger function. Using the chain rule, you know, the chain rule says the y dx is equal to the y du times the u dx. So it means that the y, the x here, will be equal to 1 over square root of 1 minus u squared times the u dx. So I'm going to paste it again. Good thing I can paste and not have to rewrite everything over. Good. So this cancels this. Then this is equal to, I can bring back the u here. Since u is 2 to the power, so I have 1 minus 2 to the power of x squared over x squared, then times, let me copy and paste, copy, paste. This is basically the answer, but if we like, we can simplify a little bit further. So we can rearrange this denominator to be square root of x squared minus 2 to the power of x squared over x squared, then times this guy, let's paste it. Well, some may be tempted to say square root of x squared is x. I won't be part of those that will be tempted. So the square root of x squared is absolute value of x. So if I'm going to actually move further from here, the best I can do is to say this is absolute value of x over the square root of x squared minus 2 to the power of x squared times, well, we can factorize the expression that we have here. I can see that there is a 2, there is an x, there is, so if we bring out the 2, then there is an x squared plus 1, because this is 2 to the power of x squared, this is 2. And there is an x, There is an x here, there is an x here. So into brackets, we'll be left with x squared natural log of 2, then minus 1. Yes. Over x to the power of 4. Well, one of these x can take care of one of these. So this, I believe, is going to be the final answer to the derivative of that ugly looking, or is it ugly? Is it beautiful? Well, beauty lies in the eyes of the beholder. That is where we are going to end this video. Till we will meet again, enjoy mathematics, have fun, and see you later. Bye.